Alright, so in this video, we're going to be talking about converting polar to Cartesian. Okay, so all you really need to know about these, Cartesian polar conversions are these three things right here. X equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. Now, where do we get that from? Well, actually, if you have one point, right, say we have our polar axis down here, okay, and we have a point up here, r comma theta, right? That means that the distance here is r, and then we have the angle here, which is theta. Okay, so we can say that this is the x-axis, right? So we have an x here, and we have a y here. Okay, so it's kind of putting the coordinate plane, the xy coordinate plane, onto the polar plane. Alright, so in this video, we're going to be going over conversions from polar to Cartesian. Alright, so all you really need to know to convert between polar and Cartesian is x equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. Okay, so how do we even get these conversions, right? Where did they actually come from? Well, if you have a point, right, if you have r comma theta up here, okay, well, you have to, right, you're traveling r to get there and in the theta direction, I guess you could kind of say, right? But you can also describe how you get to this point with just Cartesian coordinates, right? So you go over x and you go up y. Okay? And here we've created a right triangle, which we can do Pythagorean theorem with to get that r squared equals x squared plus y squared. Okay, so that's where the first thing comes from. Now, if you take the cosine of this angle, okay, let's take the cosine of this angle here. Well, cosine of this angle is going to be adjacent over hypotenuse, right? Which is x over r. Multiply r on both sides, and of course you will get x equals r cosine theta. And this is exactly how we get the last one here. Sine theta is going to equal y over r. Okay, it's equal to opposite over hypotenuse, right? That's y over r. That's y equal to r sine theta. All right, and there's another one that you can remember. If you take the tangent of this angle as well, then you'll end up with y over x. But you don't really need, I mean, it's easy to remember this, but you don't need to, because honestly, if you put y over x, you can see that you get tangent theta, right? You have y over x, you have r sine theta over r cosine theta, and of course that's just tangent theta. Right, so you kind of see proof of that right there. Okay, so we're going to do one quick problem, and that's going to be it for the video. Okay, so convert 2 comma pi over 3 to Cartesian coordinates. Okay, so we know that our r is 2 and our theta is pi over 3. And all we need to do is just plug that in here to get your x and your y. Okay, so doing our x first, we're going to get that x equals 2 cosine of pi over 3. Alright, and that's going to be, well, pi over 3, that is 60, right? Cosine of 60 is 1/2. You multiply that by 2, that's just going to be 1. Now, for y, that's going to be equal to 2 sine of pi over 3. Sine of pi over 3, that's going to be rad 3 over 2. We're multiplying by 2, so it's just going to be rad 3. And so making that conversion, you see that 2 comma pi over 3 ends up being 1 comma rad 3. Okay, so converting with points is actually fairly easy, right? But in the next video, we're going to be focused on converting polar equations to a Cartesian equation. Okay, so that's going to do it for this video.
So if this video helped you, make sure you leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar and the next video in this series. See you soon.